Hey Go Matters, and hello students and parents. Today we're going to be talking about coordinate planes. Now we have learned about this previously, but I think it's always important too that we have review. It's making sure that we so know and understand the concept, not just because we learned it just for that chapter or that lesson that week. So coordinate planes is a skill that we learned in the past, usually around like 4th, 5th grade. And so for 6th grade, we use coordinate planes to graph ratios, to set graph functions. So we came up with a new creative game to practice our coordinate planes and graphing. And so I asked the class, when we were thinking of games and how we can review and practice this concept, I asked my students, I'm like, have you ever played Battleship? And literally had like one hand, maybe two. I'm like, how crazy is this? How have you never played Battleship? This is such a classic game and a great way to practice graphing. So our version is that you take a piece of graphing paper, and we have a clear protective sheet here. And on the graphing paper, we first talk about everything that you need to know to make a coordinate plane. So we first talk about the x-axis, and we talk about how that's the horizontal number line, or the number line that goes side to side, and we have the y-axis that's going vertically, and when those two intersect, we make a coordinate plane. And so some of the parts that we need to know is where the two intersect, we call that the origin, or it starts at 0. And for some reason, coordinate planes, they are very challenging for students to understand, but I try to make sure that students understand it's just number lines. So when we're looking at just one axis, for example, the x-axis, we always start at the origin, and anything to the right of the origin on the x-axis means that it is greater than 0. So we start off with positive numbers, 1, 2, 3, 4, and we go all the way until we essentially run out of graphing paper. And I said it can go on and on forever. We have arrows to indicate that it could go on and forever. So if we had enough, graphing paper, we can graph until our hearts are content. But for this purpose and for the game, we did it in increments of 1. But keep in mind, when you're graphing, you can do increments of 5, 10, hundreds, okay, whatever is suitable for the problem. Now, anything to the right, sorry, I'm backwards here. Anything to the left of the number line of the x-axis is less than 0. So when we're talking about less than 0, now we're talking about negative numbers. So we have -1, 2, 3, 4, and so on. And that is just our x-axis. Now when we talk about the y-axis, I always think of these as like thermometers. So the higher on the thermometer I go, the bigger the numbers, right, the hotter the temperature. Well, on a coordinate plane, we said we start at 0, and then we count 1, 2, 3, 4, 5, and so on. Common mistake for students is that they will start up here and say 1, 2, 3, 4. So key is always start at the origin. Now if I go down on the y-axis, these are numbers less than 0. So again, we are entering negative numbers, -1, 2, 3, 4, and so forth. Now, you may be seeing these Roman numerals here and thinking, what are these? Well, when we make a coordinate plane, we essentially are creating 4 quadrants. And so we label as quadrants, and we go in a counterclockwise manner. And so we have quadrant 1, 2, 3, and 4. So when we're looking at quadrant 1, we know that all of our ordered pairs are going to be positive, because everything on the x-axis are positive values and everything on the y-axis are positive values. So quadrant 1 would be a positive for a positive x and a positive y. Moving over to quadrant 2, we would have a negative x-axis and a positive y-axis. So these numbers would be graphed if you had a negative x and then a positive y. Quadrant 3 is all negatives, because we have negative y values and negative x. So both your x and y coordinates are going to be negative. They'd be graphed in quadrant 3. And then quadrant 4, we have positive x and a negative y. So these are just the essentials that we need to know when it talks about a coordinate plane. But then we have to talk about how do you use a coordinate plane. So like Battleship, we created our own ships where I just had simple index cards, and I had a list of Battleship points. So we started off with only like 3 points, And so I would have ships like A, B, and C, and I would make them set Battleship A would be 1 ordered pair, Battleship B would be 2, and Battleship C would be 3. So very similar to the Battleship game itself. And I said you can make as many battleships as you like. You can make them having only 1 value, 2 values. You could do 6 values. It's personally up to you. So that kind of makes it fun in that you can make it to your own liking. So if it's for your own class or if you're doing it at home, you can do whatever you like. So if I had an example like -1, 2, kind of some quick examples here. If I had Battleship B, let's do 2, 2, and then we'll do 2, 3, and then we'll do, 2, 4, drop the eraser. And then we'll do Battleship C. Let's do 0, -1, and we'll do 0, -2. So essentially, these values I put on an index card, and the students would each pick their own index card. Each student would have their own graphing paper coordinate plane, and then we have privacy folders, which are essentially just cardboard that separates the students so you can't be peeking at each other's paper. So with your coordinates or ordered pairs, the student would first graph their points. So if these were my values, I would take my paper and I would graph these points at -1, 2, and I would label them. So point A, B was 2, 2, 2, 3, and 2, 4. C was 0, -1, and then we had 0, -2. So I would first graph them myself. So my battleships look like this on my coordinate plane, and so this way the students have individual practice on just graphing points, but then when it gets to the actual game, then the students would sit across from one another and they'd ask, okay, I'd ask my opponent, do you have a battleship in quadrant 1? Okay, so if my opponent had a battleship in quadrant 1, they would say yes. If they say yes, then I can take a guess and say, do you have a battleship point at 2, 2? So if I'm using my example and I have a battleship at 2, 2, I would say that's a hit. So I put an X there. And so if you get a hit, the student gets to keep guessing, and eventually if they figured out that my Battleship B was going vertically, then if I have all of my points are hit, then say Battleship B has sunk. And so then they would check off Battleship B has sunk, and then we keep going back and forth. If I would ask them and say, hey, do you have a battleship in quadrant 3, and there was nothing there, they'd say no. Then it'd be their turn. I would then take another turn and say, do you have a battleship in quadrant 2? They say yes. I take a guess and say, oh, is it at -9, 3? And they say no, it's a miss. So then I would circle it knowing that that is a miss, so I don't want to guess that again. And we essentially go back and forth until one person has sunk in the other opponent's ships altogether. And it's a really fun interactive game. It's very similar to the game Battleship itself, but more geared towards what we're practicing in class, which is graphing ordered pairs, and also to determining where a point should go on a graph, and all the essentials of a coordinate plane, including quadrants, X and Y axis, and then the origin as well. So again, super fun, super interactive, something that you can do at home, and something that you can practice together as a family. So be sure to check it out, give it a try, let me know how it goes, leave a comment down below, and be sure to subscribe to our channel, and go check our website, gomadforlearning.com.